What makes people want to do their best? Can you force somebody to do their best? Lean, Agile, Scrum, SAFe, Kanban, everything that we talk about. The ultimate goal of all of these things is to build a high-performing team, a high-performing portfolio, and a high-performing organization. Would you agree? What is Lean about? Lean can be summarized in much fewer words than Agile can be, in my biased opinion. Lean is primarily about reducing or eliminating waste. Right? Everybody's heard of that term, reducing waste or eliminating waste, so that we can maximize value. Now, Lean and Lean Agile software development has become a big buzzword in the tech community over the last few years. Have you heard of that? Lean Agile or Lean Agile being used in conjunction quite a bit, right? And there's many frameworks that claim to be Lean Agile frameworks. Kanban is a lean practice, but often used in conjunction with Agile practices. Are we using Kanban boards at work? Anybody seen a Kanban board being used? Raise your hand if you are, just to check in. Yeah, many of us, right? So Kanban boards are coming from the lean side of things, and they help us make our work visible. So understanding waste is a critical part of developing a lean agile mindset, and more specifically, a lean mindset. So what we're going to start our lean conversation with is understanding the different types of waste that could be present in a system. These 7 types of waste are go by the acronym TIMWOOD. And the premise here is that each of these 7 types of waste, or all of these 7 types of waste, are present in every system. Understanding these 7 types of waste and being able to identify these 7 types of waste is critical to our ability to build a lean mindset in our practices and approaches. Okay, so we're going to go through these 7 types of waste one by one, and they go by the acronym TIMWOOD, as you can see. So let's go with the first one is transportation. What is transportation? Transportation refers to excessive movement of goods and services in a system. Excessive movement of goods and services in a system. So let's take an example of that. Question for, this time a question for Verb. Verb, quick question for you. Have you seen this happen? A product owner identified a requirement, and a developer coded that requirement. But the developer did not understand the requirement clearly enough, so it did not pass the test, and they had to go back to the product owner to understand what that requirement meant. And the cycle went back and forth a couple of times. Have you seen that happen?
Yeah, it's a typical situation.
Typical, right? Pretty common. And this is an example of transportation waste, that back and forth movement of work in a system. Because according to Lean, work should be done right the first time. If it's not being done right the first time, it is contributing to some kind of waste in our processes. And a mindset in Lean that enables that is called pokyoke. Now, what is pokyoke? Pokyoke is a Japanese term, which in English basically translates to mistake proofing. Now, what is mistake proofing? Mistake proofing simply means develop your processes, systems, structures such that we make it difficult for a user to make a mistake. So what's an example of mistake proofing? Have you seen, let's ask this question to Stephanie. Stephanie, have you ever filled out a PDF form for an application or something online where you fill out that entire form and then you click submit and then it gives you an error message? It says, hey, you missed out on that cell up there, and sometimes even highlights that cell. Have you seen that?
Yes, sir, I have.
Yeah. What is that? That's an example of mistake proofing. They're making it difficult for Stephanie as a user to make a mistake. Now, how would that apply to our world? Back to you, Verb. So do you think we can come up with some templates, some checklists, some structures for our product owners to communicate with our team members that would enable them to get it more so right the first time? Even if we may not be able to eliminate it, but we can reduce that rework to a certain extent. Do you think something like that would work?
Yeah, sure.
Absolutely.
Right? Those templates, checklists, and that is a way to reduce that transportation waste, training our people on writing better requirements, writing better acceptance criteria so that we have less of that back and forth movement. With me on the transportation waste? So back and forth movement of work. Let's go into the second one. It is, in my biased opinion, this one is the most prevalent form of waste in our systems. And this is inventory waste, inventory or inventory. So to understand this inventory waste, we're going to take an example. And this example is going to be going into Anne's car wash. Is that okay, Anne?
Sure.
So we're going to go into Anne's car wash. Now, Anne's car wash is a pretty fancy place. It is set up in 4 bays. It's not an automated car wash. It is a hand car wash. Okay. And we've set it up in bays. What are the 4 bays? We got a registration station. Then we got soak, where we make the cars wet. Then we got soap, where we apply soap. And finally, and it's got rinse and dry. These are the 4 stations that the car wash shop is set up. Cars come from the left, they go out from the right. Anne has 1 employee in registration, 2 employees in soak, 2 employees in soap, and 2 employees over here in rinse and dry. It takes each car 5 minutes in registration, 10 minutes in soak, 15 minutes here, and 30 minutes here. With me so far?
Yes.
Okay. Here's my question. What is the capacity of the registration step? Open to everybody. How many cars can this car wash shop register per hour? Just the registration.
12.
12.
I heard 12, which is right. 12 per hour. Everybody with us? How we got to 12? 5 minutes per car. So in 60 minutes, we can do 12 cars. What about the next one? Soak. How many cars per hour?
6.
Could be 6,
3.
right? Now we can assume, we're going to make
3.
an assumption.
Times 2.
We're going to make an assumption that those 10 minutes is, and there's 2 employees, and those 2 employees can work in parallel on 2 different cars, which brings it back to 12 per hour.
12.
Let's go into the third one. This one is going to become 8 per hour, and this one becomes 4 per hour. Everybody with us?
Yes.
Yeah. Okay. How many cars can this car wash shop collectively serve per hour as 1 unit?
4.
Why 4, Dipen?
So that's maximum which can go out.
Exactly.
I think
Because
that's inside.
capacity of the bottleneck is the capacity of the
System.
Now let's understand inventory waste, where it shows up. So let's say you go to Anne's car wash shop in the morning, and Anne opens the doors, cars start coming in from the left. They go through registration at a good pace of 12 per hour. They go pretty seamlessly into the soak station because the capacity is the same, right? They go into the soak station. What's going to happen when they hit the soap station?
Slow down.
Slow down, and there's going to be a
Pile up of cars
pile
waiting.
up of cars, right? Cars are going to start piling up over here, but they eventually go into the soap station. And then what happens over here? Another pile up of cars over here. And they eventually make their way out, and the business delivers value at 4 cars per hour. With me, Bhagya, on this so far? Ciao, right? Okay. Now these cars that are mid-process, partially complete, waiting for the next step is what inventory waste is. So what is inventory waste? Mid-process, partially complete work, waiting for the next step. And this, in my biased opinion, is the most prevalent form of waste in our systems. And this car wash shop metaphor that we're using is basically our flow of work, as we call it, from concept to cash. Concept to cash is basically an industry slang, which basically means taking something from an idea all the way to our customer. You with me? Taking something from an idea to our customer. And as we take something from an idea to a customer, you would notice that often there is inventory that builds up in the process. For example, code that has been written, not tested. Code that has been tested, not integrated. Code that has been integrated, not deployed. Have you seen that?
Yes.
Is code that is stuck somewhere in between concept and cache, is that code or system delivering any value to anybody?
No.
Right? And it's just sitting there and building bottlenecks in the system. So what do we see in these type of organizations? Over time, what's going to happen is that this entire car wash shop is going to become a 4 per hour car wash shop, right? People are going to sooner or later realize that, okay, we work at 4 per hour, so let's become a 4 per hour shop. So how does this happen? How do we become a 4 per hour shop from those people that could have done 12 per hour? Here's how it happens. How does somebody go from 12 per hour to 4 per hour? First, let's understand what happens to these 4 per hour people, which are the bottleneck. These people are working evenings, weekends. You send them an email. They have a big backlog of things. You send them an email with a request. They're like, yeah, MC, we can help you out with it, but you'll have to wait till September. Have you seen that? Have you seen a department that has a big backlog of stuff? Right? That is a bottleneck department because they have more work, less people, and things are starting to pile up in there, right? And what happens to these 12 per hour people? How do they become 4 per hour? They're going to the gym at 2 o'clock. Then at 3 o'clock, they're buying groceries for home. Have you seen people buy groceries for business hours, in business hours? But those are often these 12 per hour people that are having to work at 4 per hour. And it's not their problem. It is a problem of the system. So one of the key principles in systems thinking, and I'm going to invite you to note this down because it's obvious stuff, no rocket science, but the impact and the perspective shift it would bring is very powerful. Here's the principle. It says, blame the system, not the people. Blame the system, not the people. Problems come from the system, not from the people. People behave how a system enables them to behave. Problems emerge in the system. And that system is going to be flawed, right? Once this is the bottleneck, then there's not enough work for these people, then this department becomes a bottleneck. Then somebody else becomes a bottleneck. And it is going to be a problem of the system over here. With me on inventory waste, mid-process, partially complete work, waiting for the next step. Let's go to the next one. M refers to Motion. Now, this is one that is slightly less applicable to our tech teams, especially these days. Motion is physical movement of people. So that is people flying around for meetings and so on, right? Because when we're flying around, when we're walking around from room to room, we're not producing value for a customer at that time when we're moving, right? So this is one that we're slightly less focused on, but it shows up in our Scrum teams and our Agile teams in the form that we want our teams to be co-located as much as possible. Have you heard that? Right? We want our teams to be co-located, be in the same area, sit in the same room if possible, because that reduces motion waste and enables them to collaborate more seamlessly. The type of businesses that focus on this motion waste a lot are businesses like McDonald's. When McDonald's restaurant is designing its kitchens, they set them up such that a worker in the kitchen does not have to take a step when they have to make a burger. Why? Because when they have to take that one step, let's say I have to take one step, bring something back to make that one burger, how many times I'm going to have to take that step every day? 1,000 times. And those 2 seconds that it took me to bring something back, those 2 seconds are going to start to add up. And that then slowly becomes, according to McDonald's, the difference in between a profitable store and a non-profitable store. One step in the kitchen, right? So that's motion waste. As I said, slightly less applicable to our tech teams, especially these days with remote work becoming more and more common. Let's go to the next one is waiting. What is waiting? Anything that is waiting for approvals, waiting for sign-offs. Now, as you notice, inventory and waiting waste are kind of connected, right? Because when those cars were in that inventory phase, they were also waiting for the next step. But waiting is mostly referred to for organizational issues, while inventory is referred to for capacity issues. So for example, I've done a lot of work with US Air Force. For some of our teams in their portfolios in US Air Force, we have to get 23 approvals, 23 actual physical signatures on a piece of paper if we want to accept a change in the backlog. I'm not making this up. It's actually 23 approvals that we need to take. And sometimes our teams are waiting for weeks and months before we have anything to do. So anything that creates that waiting waste, approvals, sign-offs, and so on. With me? Keep going. The first O refers to over-processing. Over-processing is quote-unquote overkilling something, doing more than what is required. Some people call it gold plating the process. Too many meetings, too much documentation, 50-page business case to be written to get an approval for something. Who wants to read a 50-page business case? Who wants to write it? Then why are we using them? Just stuck in the status quo. Over processing. Steering committees all around us. Most leaders, managers that I see around me are spending their entire day on meetings. Have you seen that? And they work after 5 o'clock. Over processing, right? We got to start thinking about what can we eliminate from our process? What's not needed? How can we cut down time on our meetings? One of those things that we implemented in one of our teams is that we're not going to have meetings beyond 30 minutes. If we need a meeting beyond 30 minutes, we've got to really think about it. Does it really need to be beyond 30 minutes? Most meetings can be 15, 20 minutes. Would you agree? If we really get to the point and if we really keep things concise, most meetings can be done in 15, 20 minutes, right? So over processing. Second O refers to overproduction. What is overproduction? quote unquote over producing more than what our users can consume. Now we have less of this problem. I think we have a bigger problem of underproduction, but overproduction example could be, for example, a lot of managers that I see around me receive more PDF reports in their inbox than they have the time or the desire to look at. Have you seen that? A lot of PDF reports being sent out. Now, that's not what makes it a waste. What makes it a form of waste is that what's on this PDF report is also on this dashboard, is also on another dashboard. Have you seen that? A lot of duplication of effort happening in our systems. And that is what overproduction is: redundancy of work, duplication of effort, multiple teams doing similar things, multiple dashboards presenting similar information, and which kind of goes into this idea of defects. Sometimes the information in those two dashboards does not even match, right? So defects is anything that does not meet the quality or the customer standard on the first try. So these are the 7 primary types of process wastes that Lean stands for. And as I said, the premise is that all of these types of waste are present in every system. Are you able to identify most of these types of waste in processes around you? If yes, give me a thumbs up. Yeah, are you able to identify most of these types of waste? That is the intent. The goal of Lean mindset, the goal of Lean Agile, thank you. The goal of Lean Agile software development is to identify those wastes. That's the first step, right? And then strategically reduce and eliminate these wastes from our process. And that is what our Lean mindset is. So here's some of the courses that we would invite you to look into if you want to go deeper into these practices, depending on the role that you play. So SAFe Agilist is a 2-day course. Most of these are 2 days, except for the Lean Agile architecture one, which is 3 days. Every other course is a 2-day course. SAFe Agilist is often a course that people take to build a first step, to take their first step into Lean Agile software development, to understand how these things operate at scale. And then afterwards, people would often go into specific role-based courses based on the role that they are going to play in an organization.